Okay, here we go with another type of titration problem. In this one, it's not really asking you to come up with a molarity of unknown titrant. It's actually just saying here we've got the molarity of two different solutions, and we want to know how much of one do I need to titrate a particular amount of another one. And so I'm still in a situation where I'm given a couple of different things. I'm given two molarities. First of all, molarity of H2SO4. I'm given the molarity of some barium hydroxide. And I'm given a quantity of barium hydroxide solution in order to titrate. Now, I would still want to start by thinking about, what are the things that I'm not going to use to make a plan with? What are the things that I'm going to use in my dimensional analysis as per expressions? And so remember that molarities are per expressions. And so I won't use those to start any sort of planning. Now, I am ultimately asked for the milliliters of H2SO4 solution. And so that means that the basic plan is to go from milliliters of the barium hydroxide solution to milliliters of the H2SO4 solution. In order to do this, I'm going to have some mole to mole conversions because it is asking me about how many milliliters of H2SO4 will it be required to titrate barium hydroxide. So I'm going to need to write a balanced chemical equation that describes that chemical reaction in order to be able to correctly process the stoichiometry. So it's going to produce water and barium sulfate. And I've got that 2 in front of the water is all I need in order to finish out the balancing. Let me go ahead and clean this up so it looks just a little better. Okay, so I've got a balanced chemical equation. I've got a basic plan. And so let's form out a full-blown plan. Now, it's going to take a few steps, mostly because I'm converting milliliters of solution to liters of solution. So I have milliliters of barium hydroxide solution. I'm going to convert that to liters of barium hydroxide solution. Look, I spelled solution wrong over here. Let me just fix that real quick. And then once I have milliliters of barium hydroxide solution, I can convert that to moles of barium hydroxide with the molarity. And so I'm given the molarity of barium hydroxide solution here. And so I would use that in that space there. Once I have moles of barium hydroxide, I can use the balanced chemical equation to convert to moles of H2SO4. Now, I use the relationship in the balanced chemical equation for that per expression there. Once I have moles of H2SO4, I can convert to liters of H2SO4 solution. And again, I'm given the molarity of the H2SO4 solution. And so that's the per expression that would go there. And then once I've got liters of H2SO4 solution, I can use my metric prefixes to convert back to 8 milliliters of H2SO4 solution. And now, so let's put it together. It's going to be a little bit longer. So I'm going to go, I'm going to start with the 25.0 milliliters of barium hydroxide solution. And that first per expression is going to be just the definition for my metric prefixes. And now I'm going to use that first molarity. The 1 liter of solution for barium hydroxide was 0.00840 mole of barium hydroxide. Now comes the balanced chemical equation. For the balanced chemical equation, I see that 1 mole of barium hydroxide requires 1 mole of H2SO4 for the titration. Now, in order to convert that to liters of H2SO4 solution, 1 liter of solution, 1 liter of solution has 0.116 mole H2SO4. And then finally, to get to milliliters, I know that 10 to the minus 3 liters is 1 milliliter. And that gives me the full step-by-step stoichiometric analysis. Okay, when I do this into my calculator, I get 1.81 milliliters of the H2SO4 solution. And that's the final answer for this problem. Okay.